of elimination reaction is greater as compared to substitution. Students, just like substitution reactions, we have studied two types, SN1 and SN2. Similarly, elimination reactions are also of two types, E1 and E2. So let us discuss E1 elimination reactions. It is a unimolecular two-step elimination reaction. Means it is going to take place in two steps, but in the rate determining step, only one molecule is going to participate. The substrate undergoes slow ionization in the first step, giving a carbonium ion or a carbocation. In the second step, the solvent or the base pulls off the beta hydrogen and is going to give you the elimination product. Now students, you can see in the first step that ionization is taking place, a reversible process in which this X atom is going to be eliminated, giving us a cation and an anion. In the second step, the base is going to abstract the beta hydrogen. Now why is this a beta hydrogen? Because the halogen atom was attached to this carbon atom, so this is alpha carbon, and the carbon next to it is beta carbon. Therefore, these two hydrogens will be called as beta hydrogens. So the base is going to abstract this proton. The bond between carbon and hydrogen will shift between these two carbon atoms, giving you a 1,2 elimination product. And you can see the base has abstracted a proton, giving you BH. So this is E1 mechanism. The similarity with SN mechanism is that it is a two-step process. In the first step, a carbocation is produced, and the second, the base or the nucleophile is going to attack. That is why it is unimolecular two-step reaction. Students, let us look at the kinetic evidence of E1 reactions. As you have seen that only one molecule is undergoing a change in the rate determining step. And what is that change? The change in the covalency from sp3 to sp2. That is the first step. That is rate determining step because it is the slowest step. And it is a two-step unimolecular elimination reaction. As you can see it again, that this is the slow step in which you can observe that this carbon atom is undergoing a change in its covalency from sp3 to sp2. The E1 mechanism has been supported by the study of reactions. It follows first order kinetics, in which the rate of a reaction depends only upon the concentration of the substrate. It can be written as rate is equal to K, the concentration of the substrate, which is the alkyl halide. Students, you have already studied the stability order of carbonium ions, and you also know that the substituted alkenes are more stable alkenes. So rearrangement is also possible during the course of elimination reactions. The presence of carbonium ion as an intermediate has been indicated, or it has been experimentally proved by the presence of more than one kind of elimination products. Sometimes the product that we are expecting is present, but along with it, some other products are also formed. A relatively less stable carbonium ion rearranges to give a stabler carbonium ion, giving the elimination product. That is how what product we are expecting, sometimes a changed product is obtained. Now students, take this reaction as an example. Now I am having this alkyl halide as a substrate. It is going under ionization. It is a slow step. This Br will be eliminated, giving you a secondary carbonium ion. Why? Because the positive charge is on the carbon atom, which is directly attached with two carbon atoms. That is why it is secondary carbonium ion. Now students, if this methyl could shift on this positive charge, then you can obtain a tertiary carbonium ion. So this carbonium ion is going to rearrange itself in order to give you a more stable carbonium ion. The shifting of this methyl will shift the positive charge on this carbon atom. Now this is a tertiary carbonium ion. Why? Because this carbon atom is directly attached to 3 carbon atoms and it is a more stable carbonium ion. Now students, after the formation of a stable carbonium ion, the base is going to abstract the beta hydrogen. Now this is a beta hydrogen because the positive charge is on this carbon atom. The carbon atom next to it will be the beta carbon and this will be the beta hydrogen. The bond between carbon and hydrogen will shift between these 2 carbon atoms. Why? To fulfill the deficiency of this C positive and giving you an elimination product. Now students, this sign which you can see over here is telling you that a group is being rearranged intramolecularly. Students, the second type of elimination reactions are E2 reactions. It is a bimolecular one-step reaction just like SN2. Bimolecular means 2 molecules will be participating in the rate determining step. Since it occurs in only one step, so this is the only step and the rate determining step. Now you can see that this is the substrate. The base is going to attack, giving you an elimination product in a one-step process. The attacking base removes a proton from the beta hydrogen. As you can see, this is the beta hydrogen. This base is going to abstract this proton. Simultaneously with the formation of a double bond between alpha carbon and beta carbon. This is the alpha carbon, this is the beta carbon, and the loss of the halide ion. Now you can see base is abstracting the proton. This bond will shift between these 2 carbon atoms, eliminating this X atom. Now students, just like SN2, an intermediate, a transition state, a high energy, short-lived intermediate is going to form. The dotted bonds are showing the bonds which are forming and breaking. The bond between B and H is going to form. The bond between C and H will be broken down. A new pi bond will be created between these 2 carbon atoms, eliminating this X. So this is an intermediate state. Now students, let us look at the kinetic evidence of E2 mechanism. This is the rate determining step, the only step, because the bond breaking and bond making process are taking place simultaneously in one step. Since 2 molecules are undergoing a change in the transition state in a bimolecular one-step elimination process. Thus E2 is one-step process in which both the substrate and the base is participating, and the observed rate law for E2 reaction is rate is equal to K, the concentration of alkyl halide or the substrate and the base or the nucleophile that is going to attack. So students, because these 2 molecules are participating and undergoing a change in the covalency, that is why the rate is going to depend upon the concentration of both of these reactants. Now students, let us look at the stereochemistry of this E2 mechanism. The rate of E2 reaction depends upon the concentration of substrate and base, as we have already discussed. And for this reaction, you can see that this is a nucleophile. It is going to abstract the beta hydrogen, shifting the bond between these 2 carbon atoms, eliminating this halide ion. This is the transition state. Now this carbon atom is undergoing a change in covalency as well as the nucleophile. Therefore, you are getting an elimination product, an alkene, water, OH, H is going to give you water. This Br will be eliminated. So the rate of this reaction can be written as rate is equal to the concentration of